We solved in November 2015, eh?
Yes.
Okay. November 2015, eh? Okay, so let's now go to November 2016. November 2016, question 2B. November 2016, question 2B. And just from the look of the structure, you can see there are 3 sets. So this is A, B, C, D, E, F, G, and H. There are 3 courses. One is accounting. The other one is technology. And the other one is statistics. So those are the so we are drawing the Venn diagram. So this is A, B, C, D, E, F, G, H. So we have equations and workings. Equations and workings. Equations and workings. So once you are through with drawing, you write through or finish. Those who are online, hakuna mtu amemaliza kuchora? Okay, good. So let us now read as we record. Let us read as we record. We are told that Faidika College offers 3 courses, namely accounting, information technology, and statistics. The marketing department of the college conducted a survey on 500 students to determine the number of students enrolled for each of the 3 courses. The results of the survey were as follows. Now, that far, we can be able to establish 2 things. One, that N will be 500, and the total here is 500. And the second thing that we can be able to establish is that this study involved students. It involved students. So H, which represents non-students, because for you to be a student, you must be enrolled in one of the courses. It therefore means H must be what? 0. That's all. The study involved students. We are told the marketing department has conducted a survey on 500 students. That's all. And you are already a student if you are pursuing a course. Now, H are those guys who are not pursuing anything there. Therefore, H must be 0. That one we are able to move straight on. I hope you have gotten that. H must be 0. We proceed. 329 were enrolled for accounting. So you come here and say 329 should be equal to 329 should be equal to everyone who is in accounting. So those who are in accounting are A plus B plus C plus D. $186 were enrolled for IT. So those who are inside technology is 186. So 186 is B plus C plus F plus G plus G. Those who are enrolled in statistics, they are 295. So 295 is equal to C plus D plus E plus F. 83 were enrolled for accounting and IT. So those who are in accounting and IT, it is BC where they meet. Accounting and technology. Accounting and technology, the intersection is BC, yeah? Is that so? Yes. So 83 is B plus C. 217 were enrolled for accounting and statistics. So accounting and statistics in BC. That's all? Yeah. So that is 217 is equal to C plus D. C plus D. And then 63, we enrolled for statistics and IT. Statistics and IT is CF. And those ones are 63. 63 is C plus F. And that's all. So I told you yesterday that once you have formed the equations, if you're not able to get a SIGO one, what you do, you now bring the whole equation. So the whole equation should be 500 is equal to A plus B plus C plus D plus E plus F plus G plus H. So we start looking for the components of this. So you can see the whole of this block is known. A, B, C, D. Here. Then this EF, because we know CD here, this CD is known here. It means that even EF is known. And we also know H. So we are only now left to look for G, which we will say G should be 500 minus ABCD, which is 329, minus EF. EF is 295 minus CD. CD is 217 minus H, which is 0. Brian, I can see your issues, your statement, but I don't think that is the right forum to raise your concerns. Okay, so give me the answer. 93. So G is 93. So we come and give 93 here. Then from there, this equation has assisted us. That equation has assisted us. And the latest value we have gotten is G. So we look for G. To kipibia hapa, we find it is there. And we also know BC. BC is also known. BC is also known. So we are able to get F as 186 minus BC, which is 83, minus G, which you have gotten as 93. So when you get that, the answer is 10. So F is 10. Okay, we proceed This one, hii ndio imetusaidia na tumeshukuru, we mark it out. Then we check where we can get F, and when we get here, we are able to see F. So this F is known. So based on that, we are able to get E as 295 minus CD, which is 217, minus F, which is 10. So E becomes what? 68. E is 68. So this equation has assisted us, and that is good. Then from there, we get here. Let's come here, where we know F. So based on that, we are able to get C as being equal to 63 minus F, which is 10, and you get that one is 53. So 53, C is 53. Hii ndio imetusaidia, tumeshukuru. So based on that, tukuje hapa kwa D, where we now know C. Ndio tuseme D is equal to 217 minus C, which is 53. So that gives us what? 164. So D is 164. So you run here and record 164. So this one has assisted us. Then we come here. We get C, helping us to get B as 83 minus C, which is 53, and that gives us what? 30. So B is 30. Then this other one, look for A from there. Look for A. 1 minute. Umepata the value of A to be 82. And when you add them, are they going back to 500? Good. So now, the question is Roman 1. Roman 1, illustrate the above information in a Venn diagram. So Venn is already provided. Number 2, the probability that a student enrolled for all the three. The probability that a student enrolled for all the three. All the three. So we can just say probability of the three. Yesterday I told you the general formula of computing probability is desired, you divide by possible. So we desire those who are in all the three. And those who are in all the three, they are C. And the possible, all of them are what? 5 and N. So C will be 53 and N is 500. You are already through that? 0.106. Good. The next one is probability that a student is enrolled for accounting or statistics, but not for information technology. So this is how you argue it out. We want accounting or statistics, but not technology. So these guys, anyone who is asked by technology, we leave them out. So we'll be left with A, B, E. So that would be A plus D plus E. These ones, you divide by N. And this will be equal to 82 plus D, which is 164, plus E, which is 68. You divide by N, which is 500. Is that okay? 0.628. So those who are online, if you are okay, same okay, so that I proceed to another question. Yeah, okay, let me know. Yes, Pfizer, Catherine, yes, Barbara, Redon, yes, Quinta, Winfred, good. So let's look for another question. Let's look for another question that we can use to cement our knowledge. Good. December 2017. December 2017, question 1C. Let's quickly get there. December 2017, question 1C. December 2017, question 1C. So quickly draw the Venn diagram. Quickly draw the Venn diagram. So we are saying it's the question of December 2017, question 1C. And it has 3 sets. Moja anaitwa fetch, mwingine anaitwa jet, mwingine anaitwa met. So quickly draw that. Na ukimaliza useme finished so that we proceed from there. When you are through, you say finished, so that we read and solve together. Yeah, finished. You can start now. Has disappeared. So we are told that a survey was conducted on 800 households to determine their preference for 3 consumer goods, namely facts, jets, and mix. The results were as follows. So that tells us here it is 800, and when we will have finished, we will get ourselves 800 there. Then we are told 230 households preferred facts. So 230 is facts. That is A plus B plus C plus D. That is 230. 245. Is it 245? Yes. 245 preferred jets. So 245 is jets. That is B plus C plus F plus G. 325 preferred mix. 325 is met. That is C plus D plus E plus F. You're getting the 30, yeah? Is it 30 or 80? Those who preferred the 3. I hope it's not very clear. 30. So 30 preferred all the 3. So 30 is C. 70 preferred facts and jets. Facts and jets, that is CB. That is 70 is C or B plus C. 110 preferred facts only. So facts only is A. 110 is A. 185 preferred max only. So max is E. Only, that is 185. That is E. So with that now, we are now able to solve a few of them. So quickly, let's allocate these ones that we already know. E is 185 here. A is 110. B, A limejua, C limejua. So these 3 are already known. And based on that, this C will help me know that B is 70 minus 30, which is 40. So B is 40. That way, B is 40. Then, the next one, we can come here. When we come here, this one we are not able to know. But when I come here, this one, these 3 are known. Those 3 are known, so they will help me get D as 230 minus A, which is 110, minus B, which is 40, minus C, which is 30. So D is 50. So this one has assisted. Then when I come to the second one, I know BC, but F and G not yet known. This other one, I know C, D, and E. So I can comfortably tell my F. So F should be 325 minus C, which is 30, minus E, which is 50, minus E, 185. 60. So F is 60. So this one has assisted. So we can come back here and get our BC. Rather, we already know F. So G ndio haijulikani. So be able to say G must be 245 minus BC, which is 70, minus F, which is 60. So that becomes what? $115. So G is 115. So now that we know these ones should add to 800, establish the value of H. Yes, Brian, give me the value of H. Give me the value of H so that they add to 800. To 10. Yeah, that is the answer to 10. So with that now, we proceed to answer the questions. The number of households that prefer FX and JEX. So the answer to Roman 2, FX and JEX. See that one we had. So this one that we have got BC should have been CB. Because now it is FX and MEX. So this is what we shall do. This is what we shall do. In your past paper, because we took BC as FX and JEX, so where you are told 70 households prefer FX and MEX, cancel MEX and you write JEX. Cancel MEX, you write JEX, so that this one is true. Then in the requirement now we say now these were FX and MEX. Yeah. So in the requirement sasa tujibu hiyo. So in doing that, FX and MEX is CD. So C plus D is 30 plus 50, and that is 80. And then the probability that the household selected at random does not prefer any. So those who do not prefer any, the probability should be H out of N. And H is 210. You divide by 800. 210, you divide by 800. $0.2625. So now On your own, I propose you handle the following. You handle the following on your own for more practice. November 2018. November 2018, question 1D. November 2018, question 1D. You handle that. And then you handle May 2019. May 2019, question 1C. Question 1C. That will be very, very good of you. So with that, I therefore seek to proceed and I told you yesterday that probability theory is founded on 3 areas: set theory, rules, and distributions. So we have now discussed fully set theory, and time has come that we now need to discuss probability rules. Probability rules. It is obvious that rules, they guide how things should be done. Rules guide how things should be done. So the first rule that you will come across is called limits rule. Limits rule. So this rule states this way, this rule states that the lowest value of a probability, this rule states that the lowest value of a probability is 0, and the highest value is 1. And the highest value is 1. That is probability of any event is like that. That's limits rule. So that tells you if you compute any probability and you get a value greater than 1 or less than 0, you are wrong. Number 2 is called total rule. Total rule. Right, this states that the probability of an event happening, plus the probability of an event not happening plus the probability of an event not happening should be equal to 1. Should be equal to 1. That is probability of A plus probability of A naught should be equal to 1. Probability of A plus probability of A naught should be equal to 1. Actually, this one, you can also call it complement rule. You can also call it complement rule. If you add all the possibilities, they should be equal to 1. The next one is called addition rule. Addition rule. Addition rule. We write that this is used to handle or to analyze. This is used to analyze mutually exclusive events. Mutually exclusive events. First off, these are events that cannot take place. These are events that cannot take place at the same time. They are events that cannot take place at the same time. First of all, they are union of sets. They are union of sets described by the word or. Described by the word or. First of all, it is stated as probability of A on B is equal to probability of A plus probability of B minus probability of A and B. The next is called multiplication. Multiplication rule. Just a minute, I will use someone. Okay, we continue and write that this is used to analyze. This is used to analyze independent events. It's used to analyze independent events. Independent events. Stop. These are events. These are events that can happen at the same time. These are events that can happen at the same time. Stop. They represent intersection of sets. They represent intersection of sets described by the word add. Described by the word add. A and B. A and B. It is stated as, probability of A and B is probability of A times probability of B. Probability of A times probability of B. Next, anaitwa Bayesian rule. Bayesian rule. Bayesian rule. And we write that this is used to analyze. This is used to analyze conditional or dependent events. Conditional or dependent events. First of all, these are events that influence. These are events that influence each other. That influence each other. In that one must happen. In that one must happen for the other one to happen. For the other one to happen. First of all, they are described by the word given. They are described by the word given. And then you put it brackets and slash, like this one. So hii ukiona kwa probabilities inasomwa given. By the word given, namna hiyo. First of all, this rule is also used. This rule is also used to revise probabilities. It's also used to revise probabilities in decision making. To revise probabilities in decision making after acquiring new information. After acquiring new information. First of all, the initial probabilities are called prior. The initial probabilities are called prior. While the revised ones are called posterior. While The revised ones are called posterior. The revised ones are called posterior. Called posterior. The rule is stated as follows. The rule is stated as follows. Probability of A given B is probability of A and B. Probability of A and B, you divide by probability of B. This becomes probability of B given A multiplied by probability of A. So this is probability of B given A multiplied by probability of A1. Let's put 1 there. 1, 1, 1, 1. We'll be able to see those on right. 1, 1. Plus probability of B given A2 multiplied by probability of A2 plus that continues all the way to the end where you have probability of B given AN multiplied by probability of AN multiplied by probability of AN that way. Where N are all possibilities of B. Possibilities mean where B can be found. Or you had called me. Those were close. Okay, it's okay. So, have you finished copying? Okay, those are online. Have you finished copying the formula? Yes, yes, I can see yeses. Okay, then down there you write. Down there you write that conditional events are also analyzed using contingency tables and probability trees are also analyzed using contingency tables and probability trees. So for these other rules, they will be captured in these others, starting from here. So this is where I want to give you illustrations and many other questions that we shall do. They will be featuring these other rules. So the illustrations I want to use are not in your past papers. So copy example 1 or question 1. Copy as a minute. Question 1. Consider 3 identical bags. Consider 3 identical bags A, B, and C. A, B, and C. First one. Bag A contains 2 gold coins. Bag A contains 2 gold coins, comma. Bag B contains 2 silver coins, 2 silver coins, and bag C contains 1 silver coin, 1 silver coin, and 1 gold coin. First one. A coin was selected at random. A coin was selected at random and found to be defective. Sorry, not defective, and found to be gold. Found to be gold. Sorry, found to be gold. What is the probability that it came from bag A? What is the probability that it came from bag A? So I pick a solution. I have told you that Bayesian is used to deal with conditional events. And these are events that for one to happen, the other one must happen. So in this question that we have, there are two events. There is the issue of bags and there is the issue of coins. There is no way you can get a coin before you have selected a bag. So the bag must go first, followed by the coin. So then we need to analyze those probabilities, and this is how you go about it. You start where the question statement has ended. The question statement is the sentence that has the question mark, what you are told to compute. Now that question mark has, or that question statement has ended with what? Good. So if it has ended with A, you write like this: probability of A given. Probability of A given. Then you reverse, you go in a reverse way, following that sentence. And when you follow it, who next do you find? If you follow that statement now in a reversed way, after tumepata A, ukifuata hiyo sentence in a reversed manner, who do you find? Gold. Good. So that is how it's written: A, G. And as we have written in the general formula, this one will open as probability of A and G. Probability of A and G. You divide it by probability of G. So two things that you can use to cram. That these values here, A, G, they are the ones that come to the numerator as A and G. And then the second one here that you are told given is the one that becomes the denominator. It's the one that becomes the denominator. Then the other thing that you need to know is we already have said when you are told A given G, it means the probability of selecting the bag given already you have selected the coin. But we know that is not the order. You cannot first of all select the coin and thereafter select the bag. You have first of all to select the bag so that you can get the coin. So to make it practical, unapidua. Naona hii venye imekaa, unaipidua. So that now you start with the G given who? A. Na sasa hiyo mapiduzi inafanyika hapa. This way. So now this will be probability of G given who? A. So you can see the piduka. And then you multiply by probability of A, the one that you are told given. Then this G, if you remember the general formula that we have written, it is supposed to be everywhere where you can get G. Now the everywhere includes all the bags. Includes all the bags. So we are going to argue this way. Probability of getting gold in A multiplied by probability of getting bag A plus probability of getting gold in B times probability of getting bag B plus probability of getting a gold in C multiplied by probability of getting bag C. So you see the numerator, the denominator captures the three bags, A, B, C. A, B, C. So we now substitute. Now this one is the probability of getting a gold in A. And I told you yesterday, the general formula of probability is what? Just check in your notes what we wrote yesterday. The general formula of getting probability is desired, you divide by the possible. So when we ask ourselves the probability of getting a gold in A, our desire is gold. That's all. So when we go to A, how many gold coins are in A? How many? Two. And A has how many coins in total? Bag A in total has how many coins? 2 also. So the probability of getting a gold in A is 2 out of 2. Good. We multiply by, what is the probability that you will select bag A? 1 out of 3. Good. Because our desire is 1 bag and we have 3 bags. The possibles are 3. Then all this will be divided by, and something else you should cram is this, that this numerator here, ndio inakuwa ya kwanza hapa. You see that? This numerator is the one that is here. So we then say 2 out of 2 times the third, or when we go to bag B, how many gold coins does it contain? 0. So our desire is 0, and the bag has 2 coins. The probability of getting bag B is a third. Then we go to C. C, the probability of getting a gold in C is what? 1 out of 2. And the probability of getting C is a third. So work out that and send me the answer. Those who are online, I hope you are following. And you confirm that by giving me the answer. Those who are online, I need an answer. Yes, Brian, 0.278. Someone else to confirm that figure? Getting a different one. I think I also need my card so that I can also be a witness. Yes, Barbara and Wilfred are giving me 0.67. Yes. So Brian, check yours. Check yours again. I think it's 0.67. Yeah, 0.67. Okay. So copy another question. Okay, good, Brian. Copy another question. When a machine is set correctly, it produces 25% defective. It produces 25% defective. Otherwise, it produces 60% defectives. Otherwise, it produces 60% defectives. First of all. Okay, let me repeat. When a machine is set correctly, it produces 25% defectives. Otherwise, it produces 60% defectives. Full stop. Barbara? Good. The chances that the machine is set correctly are 55%. First, one item was inspected and found to be defective. First of all, what is the probability that the machine was not set correctly? What is the probability that the machine was not set correctly? That the machine was not set correctly. So we can argue like this. Probability of, I've told you, you begin where the question has ended in the question statement. So it has ended with the machine was not set correctly. So we can say not set correct. Can use those initials, not set correct. Given you go back, who do you find? Who do you find as you go backwards? Let me see from the online people also. As you go backwards, who do you find? Let me see from the online people. Yes, Redon, good. We find defective. Yes, Brian. Yes, yes, Barbara, Winfred, Quinta, good. So we find defective that way. So as I have told you, this one will now be not set correctly and defective. Not set correctly and defective. You divide by probability that is defective. I've told you that these two things, they come here and they become an intersection. Then this one that you are given becomes your denominator. Then you come down here, na unapidua hii, this one. So that itasoma probability of defective given not set correctly, and then you multiply by the probability of this one. Probability that we are not set correctly. We are not set correctly. Then I have also told you the first one, the numerator becomes the first here. So probability of getting a defect when we are not set correct. Probability of not set correct. Or the second possibility is getting a defect when we are set correct. So probability of getting a defect when we are set correct multiplied by the probability of set correct. Probability that you are set correctly. Higher. Let us now try to get the probabilities. We are told that when the machine is set correctly, it gives us 25 defectives. Otherwise, it gives us 60. That means when you have not set it correctly, you get 60% defectives. So the probability of getting a defect when we are not set correct is 0.6. 0.6. Then we are told the chances that the machine is set correctly are 55%. That's all. That means the probability that the machine is not set correctly must then be 45%. Must be 45% that we are not set correct. Therefore, we proceed and get 0.6 times 0.45 plus probability of getting a defect when we are set correct. Probability of getting a defect when we are set correct is 0.25. And the probability that we are set correct is 0.55. Is 0.55. So work out and send me the answer quickly. Zero point 663. Okay, someone else to confirm? Barbara asking where the 0.6 is coming from. This one. Maybe that's a statement we have not gotten clearly, where we said when a machine is set correctly, it produces 25% defectives, otherwise it produces 60. Barbara, Barbara, are you able to see that? Barbara? Okay, good, good. Yeah. So the answer is confirmed. So we can proceed. Copy example 3. Example 3. In a certain company, production is done using 3 machines. In a certain company, production is done using 3 machines, X, Y, Z. X, Y, Z. In proportions of 50%, 30%, and 20% respectively. And 20% respectively. First up. 2% of the items produced by machine. 2% of the items produced by machine X and machine Y are defective. And machine Y are defective. While 3% of Z are defective. 3% of Z are defective. First up. If a unit is selected at random, and found to be defective, what is the probability that it came from machine Z? What is the probability that it came from machine Z? So once again, we begin. So we have to start with what? Z. That's where the question statement has ended. And when you go backwards, who do you find? Defective. So Z given defective. So that this will open up as probability of Z and D. Probability of Z and D. You divide by probability of D. Probability of D. Then I've told you, when you get here, unafanya mapinduzi. So in during this one, we will have probability of a defect coming from Z, or given Z. You multiply by probability of Z. Probability of Z. Now divide this by probability of a defect given Z multiplied by probability of Z. Or you can now get a defect from the other machines. So probability of a defect given X multiplied by X plus probability of a defect given Y, that is now Y, multiplied by probability of Y, the probability of Y. So we begin. A defect coming from Z. Z is producing 3%. So it is 0.03 effective. And the proportions of those that are coming from Z, they are 20%. So 0.2. So then down here we have 0.03. You multiply by 0.2 plus a defect coming from X is 0.02 and X is producing 50%. Y getting a defect is 0.02 and 0.3 there. So work out on that and give me the answer. 0.273. Good. Copy this one now. Excel Audit Company, Excel Audit Company has engaged three audit trainees. 3 audit trainees, Odhiambo, Koech, and Mwai. Odhiambo, Koech, and Mwai. First off, after 3 months, the audit supervisor notices that 3%, 5%, and 4% of the accounts audited by Odhiambo, 4% of the accounts audited by Odhiambo, Koech and Mwai respectively, Koech and Mwai respectively had some errors. Full stop. The supervisor had distributed the accounts such that 40%, 30% and 30% respectively, 40%, 30% and 30% respectively there's something else. Let me see if there's something else. Yeah, respectively were audited by Othiabo, Koech and Mwai. Othiabo, Koech and Mwai. First up. What is the probability that an account with an error was audited by Mwai? An account with an error was audited by Mwai. So you can attempt that one together with another one here of May 2014. May 2014, question 5A. May 2014, question 5A. Yeah, I can see I still have like 30 minutes. Now, for those who are online, there are some questions I've sent right now. Can you confirm whether you have seen them? Confirm that you have seen those questions. Yes, Quinta has seen them. Catherine, Denny, Pfizer, good. So with that, I told you conditional events are analyzed using Bayesian rule, contingency tables, and probability trees. So let us deal with contingency tables. Contingency tables. Contingency tables. And we write that the cells in this table, represent intersections. while totals of rows and columns represents union. First of all, the table can be used. Okay, Deba, you're saying I repeat. I have said that the cells in this table represent intersection, while the totals of rows and columns represent union. Full stop. Good. So we proceed and say the table can be used. The table can be used in relation to addition, multiplication, and Bayesian rules. Can be used in relation to addition, multiplication, and Bayesian rules. Good. So look at question 1 in the handout. Now question 1 says, in a certain factory which employs 500 men, 2% of all employees have a minor accident in a given year. Of these, 30% had safety instructions, whereas 80% of all employees have no safety instructions. You are required to find those probabilities. Now, when you read a question like that one, again, having said they are conditional, you must know which two events are there or which two experiments are there. So in this one, there are two experiments. There is the experiment of the accidents and the experiment of the instructions. And remember, an experiment is something you can further subdivide. So we already have demarcated the question into two, accident and the instructions. So based on that, we will do a table, the contingency table. We will do a contingency table that will be like this. Maybe don't squeeze the cells so that we could also have some workings there. So we are saying here we have the issue of accidents and we have the issue of instructions. And regarding the accidents, someone either had a minor accident, and I want us to call that A, or someone did not have an accident, and we call that B. Then we will have the total here. Regarding instructions, is that someone had instructions, and we call that C. The other one is someone did not have, and I want us to call that B. And then here we have the total. So that is what we call a contingency table. That way. Okay, now we can start recording. We are told the company employs 500 men. That means the grand total here is 500. The grand total is 500, so record 500 there. Then we are told 2% of all the employees had a minor accident. So those who had a minor accident, we are told they are 2%. So it is 0.02 times 500. What is the answer? All right, say the figures quickly. 10, eh? Yeah. So there were 10. When you know it is 10 there, it goes without saying that this one should then be 500 minus 10. And the answer is 490. The answer is 490. The question proceeds to say of this. Now that word this is referring to those who had minor accidents. And we are told of those 30% had safety instructions. So those who had instructions, it is 30%. So it will be 0.3 times 10. And the answer is 3. It then follows that this one must be 10 minus 3. And the answer is 7. The answer is 7. Whereas 80% of all employees had no safety instructions. So those who did not have their 80%, so 0.8 times 500. Those who did not have, they are what? That is 400. And if it is 400, it follows that this one should be 400 minus 7, and that is 393. 393. Then when we come here, this then must be, or maybe I can start here and say, this must be 500 minus 400, so that I record 100. And this one is 100 minus 3, so we record 97. We record 97. So I want us to use this table for illustration of the very many things, or the various things that you can come across regarding these tables. So if, for example, or rather, if we are told to get probability of A, you still use our formula, our general formula that says desire over the total. So we desire A. So unakimbia hapa, unapata all the A's, they are what? 10. And the total is what? 500. So just write 10 out of 500. Don't bother to simplify because of the interest of time. So, similarly, if you are told to get the probability of C, you will go to where there is C and find all the C's are 100. See there? 100, and the grand total is 500. If we are told to get probability of D, you simply go to where we have D, which is 400, you divide by 500. Those are standalone probabilities. Higher. If we are told to give us probability of A and C, right from when we began set theory, I told you the word "and" means intersection. So you go where C and A meet. Who is there? 3. So the probability would be 3 out of the grand total, 500. And similarly, if you are told to tell us probability of B and D, it will be where B meets D. That is 393 out of 500. Out of 500. Higher. If you are told to tell us probability of A or B, that is the addition rule that we discussed earlier. So sasa hii itafunguka as probability of A plus probability of B minus probability of A and B. Probability of A and B. So probability of A, we know so well, is 10 out of 500. B, we know it is 490 out of 500. Minus A and B. Now, do we have anywhere A and B they meet? No, so that is 0 out of 500. They don't meet anywhere. But if you are told probability of A or C, probability of A or C, it will be probability of A plus probability of C minus probability of A and C. Sasa, probability of A is 10 out of 500. Probability of C is 100 out of 500. Now, do they meet anywhere? Yes. Where they meet, A and C, we have who? We have 3. So 3 divided by 500. Now, just to remind you of what we discussed yesterday about sets. About sets. You see this 10, this 10 is made up of these 2 values. There is this 3 and 7. There is that 3 and 7. Then this 100 is made up of 3 and 97. And I told you yesterday that in a set, a member can only appear how many times? Once. So, ukisimamia hapa, 3 will have appeared twice because iko hapa kwa 10 na iko hapa. So, lazima tuinue hapa. So that we are just left with what? With 1. Maybe you can also note that to help you to remember. Then, if you are told to get probability of B and D, probability of B and not at all, I want all. Probability of B or D. So hii nitafungua 2 straight. Probability of B is 490 minus, not minus, you divide by 500 plus. D is 393. You divide by 500. Then you minus the intersection. The intersection of B and D is 393. No. This is D is 400. 400 out of 500. So 393 ndio ninastahili kutoa hapa. 393 out of 500. 393 out of 400. I mean out of 500. The next thing you can be told is probability of A given C. That's now Bayesian. Probability of A given C. So probability of A given C, if you remember how the Bayesian ilikuwa inafunguka, hii itafunguka as probability of A and C. You divide by probability of C. Kwa inafunguka hivyo. So sasa hii ni rahisi sana. You go where there is A and C, where they meet. A and C, they meet at 3. And then you get the value of C. C yote ni what? 100. C yote ni 100. So similarly, if you are told probability of D given A, probability of D given A, itafunguka as probability of D and A. You divide by probability of A. Probability of A. So sasa hii maneno ukipia mahali D and A they meet. D and A they meet at 7. Alafu utafute A. A yote ni what? 10. And then give me this probability of B given D. Probability of B given D, where they meet, B and D, on a 393. And probability of D, or the value of D is 400. So what we have done is all that you can come across in regard to the contingency tables. So if that is okay, I would like you to try question 2 now on your own. That is later when you go home. Together with your past papers. Do they go to December 2012? Zimefika wapi before angalia mwisho wa past papers? Kama ziko na December 2012. Okay, so kama iko December 2012 question 2C. December 2012 question 2C. Sasa hiyo imetosha ya leo. Tusimamie hapo, tutarajie kupatana in the next lesson, God willing. So you can enjoy your weekend and continue working very hard. Maisha haikuwagi rahisi, lazima upambane. At the same time, continue marketing us. We still need a lot of your support, even as we highly appreciate your support so far. So talk to your friends, tell them things are moving, and they need to join us. Thank you so much. Nice weekend.